Okay, so welcome. Welcome. And um, you guys can hear me? Okay, I can see Ankit and Jamit. Okay, so welcome, guys. Okay, this is the same code that we were working on the other day. Okay, what one mistake we made was everything is correct here. One mistake we made was that here, okay, when we are building this pre-processing steps, oh, my system got hanged. So just wait for a few seconds. Yeah. So yeah, when we're building this stop words, okay, when we are building these final words after removing the stop words, right? So this result should be a tuple. Okay, we missed to convert this into tuple. Now, if you add tuple here, this program will give us unigram, bigram, and trigram correctly. Okay, so let's see the output. So I told you unigram is single word, bigram is two consecutive words, right? So if let's say if these are the words here, each of these will be a unigram and bigram would be review ID, order ID and review score and review comment title. These are your bigrams. Diagrams would be three words together, three consecutive words together. So review ID, order ID, review score. Order ID, review score, review comment title. Okay, so review score, review comment title, review comment message. These are your trigrams. So we're going to create unigram, bigram, and trigram, and then we will populate this on a graph. So let me create this function for plotting a frequency distribution table. Okay, so I have taken a plot distribution. I'm taking the words that needs to be plotted and the color. Okay, we can change the color. Now here I'm going to say NLTK dot frequency distribution, and you take the words here, and then we will say plot, and here we'll mention top how many unigram or bigram or trigram you want to print, right? So let's say I'd say top 20 I need. So I'll say top 20. So plot 20. Okay. Is it cumulative? No, it's not cumulative. Okay, it's each individual values that we want. Okay, so we'll say cumulative false, and then we will say color equal to color that we pass. Okay, so we have created this frequency distribution function. This will plot the frequency distribution. So it will calculate the highest, then second highest, then third highest. So whenever you want to populate a histogram kind of structure with an order where you have first highest, then second highest, third highest, this is what you need to do. You need to create frequency distribution. Now to plot it, okay, I have to call this function plot distribution. And which words should we plot? We will plot first unigram, right? So I'm going to take unigram here. Let's comment this out for now, okay? This will be your assignment. Okay? Perform similar task for um, reviews that are negative. That means where your review comments, okay? So score, right? Where review score equal to 1, okay? So same thing as we have done here for review score 5, you have to do something similar for review score 1. So I'm going to take unigram, or let's take trigram here. I'll take trigram and I'll put it here. So I'm taking trigram, okay, and I'll say color is red. Okay, Let's run it. Okay, so we're getting our distribution. So now you see here, I'm going to share the plot. Okay, so this is the frequency distribution. Okay, now the words are not visible, so let me uh, take the, where's bottom? Bottom is here. Okay, so say this. What it says is these three words together has appeared more than 900 times. Bem, antes, prazo together has appeared almost 600 times. Okay, these three words together has appeared, okay, almost like 500 times. So you can go to Google Dictionary, Google Translate, and you can check the meaning of this. In fact, you can also use Google Translate in the program to translate these words. So you can translate these words before you run this frequency distribution. That also you can do it. Okay. So yes, so this is how you can take a data set, okay, review comment, for example, you can clean all the stuff like remove, um, remove your stop words, okay, remove the words which are not required, remove the words which cannot process, like, like if you have Portuguese words, remove all those accent words. Okay, once you have it ready, then okay, then you create unigram, bigram, and trigram. I told you why we should create bigram and trigram. Okay, single word sometimes may not give us a good meaning, right? If I say not good, and if you just take good and plot, it'll say, oh, it's good. But when you take bigram, you will know that okay, it's not good. Okay, so good and not good is negative, right? Not good is negative, good is positive. So that's why we need bigram. Sometimes we have to go to trigrams also. You can create even 4grams sometimes. Okay. So your NLTK gives the capability to create unigram, bigram, trigrams, 4grams, ngrams, we call it. Okay. You can create any number of grams based on your requirement. But for e-commerce kind of retail kind of business, I think trigram is enough. Okay. So now you know that, these are rating 5. Okay. So we have filtered the data for rating 5. So these are all positive comments. And why people like to give positive comments is shown onto the graph. Okay. So with that, we complete our ngram thing. Now, I will show you one more exercise where we will be using English text to perform similar steps that we have seen with this exercise. Okay. And also, I want to take one more exercise where we talk about sentiments. Okay. So let's move on there. So we are still in NLP. Now we will see how to handle English text, right? So a couple of steps. In the last example we have seen how to read a Portuguese data, right? So here we will see first how to process or work with English data. And then second example we will see is how to read the sentiment. So we'll do sentiment analysis as well here. Okay, so before doing any NLP work, first you have to install NLTK package, right? So you install the NLTK package and then you start performing each and every step. Okay, so let's see. First step I said, convert into lowercase, right? So you know how to convert into lowercase. So if the text is product is great, but I don't like the color. Okay. Or I don't is not the right thing, right? You can say I don't like the color. Okay. Let's say this is the text. Okay. So first thing what you should do, I just said, is text equal to text dot lower. Right. So now when you print your text, so I will say text equal to something like this. I'll put /n. So the output goes in different line. Okay. So now when I run it, so product is great. So we say product is great, but I don't like the color. See, it has converted into lowercase. Okay, because you don't want I to look different, product to look different, right? Whatever it is, you convert to any one case. Okay, is by word. Okay, so what is tokenized? Let me put that here. Tokenize, tokenize, right? Tokenize the content. Okay, break it into words or sentences. So if you're dealing with sentences, if you want to deal with sentences, then you'll break it into sentences. If you are dealing with words, you'll break it into words. Okay, if you don't want to use NLTK, you can always break, like you can say text1 equal to text dot split, right? So we have done this in string. So now when you print, okay, I'll keep moving this, okay, so I don't have to print it. Now this is how you split it into, oops, text1, right? Okay, so see, this is how we have split it into different words. Okay, okay. Now you can also use the inbuilt example, okay, which is tokenize, sentence tokenize or words tokenize. So you can say here, okay, I'll use it here itself. Using NLTK. So you'll say from NLTK dot tokenize import sentence tokenize and you have word tokenize. Okay. Now, if I say here text equal to, okay, your word tokenize, right? So word tokenize and you pass the text here. Okay. So now you can actually see both ways of, yeah, this is only text, correct? Exactly same output, right? Don't is two different word, right? You have do not. That's what don't means. Do not, isn't it? So see, NLTK has broken down into do and not. Okay, so it understands, okay, don't is not one single word, but it is two words together. Now comes step number 3. Step number 3 we're talking about, correct? Step number 3. Removing stop words. Words which are not significant for your analysis. For example, okay, you have, let's say an, a, right? The, it could be is, are, right? These are words which will not, see if I want to understand whether the sentence is positive or negative. Product is great, but I don't like the color. Product is important. Is not important. Product great. If you hear this itself is enough for you, good for you. So stop word, okay. So NLTK has list of stop word, okay, which you can download and you can remove, okay. But if you are not, you can always create your own list also. My stop words, okay, my stop words equal to is I, and that's why I see, okay, converting into lowercase is so important, because now if I do not convert, then I'll have to create is like multiple ways, right? All small, or cap, I cap, S small, S cap, I small, right? So four types of is I have to write. So it's always important to convert into lowercase and then start doing it. Okay. So I say is and I, for example. And then what I'll do for W in text. Okay. For W in text. Okay. If W in my stop words, then text dot, what do you say? Text dot remove W. And now you will print text after my stop words. Okay. And maybe I'll put it in the same line. Here I'll put text. Okay. Now okay, so what I'll do is I'll say text 1 equal to text. Okay. And I will use text 1 everywhere. Okay. Text 1 is like we are doing manually. Okay. And text is like we are using inbuilt NLTK method. So product great, but don't like the color. Okay. So you can put the also here. Okay. Okay. So see, product great, but do not like color, right? This is what we have created using our stop word. Now, how do you use NLTK? So for NLTK, okay, you can download NLTK, NLTK dot download, NLTK dot, I don't know why. Yeah, it is download. And then I will say stop words. NLTK, okay, I have not imported NLTK. I'll say import NLTK. This I should have done in the first line itself, right? Okay, so NLTK download happened. It downloaded stop words list. Now what I'll do, I will say from NLTK dot corpus import stop words. Okay. And now what I will do, I will say text equal to, because see the stop words have been downloaded, right? Now I have to create that. So I'll create a set. Why set? Set will remove duplicate values, right? So, and I'll say NLTK English stop words. You have stop words in every language, okay? Most languages are supported by NLTK. So I'll say here set of, okay, set of stop words dot words, and in the language I'll say English. Okay, now you want to see the stop words, so I'll say here print NLTK list of stop words in English. You can try for other languages also. Okay, you can try for other languages. NLTK stop words. See, your, should have, when, other, you will. Okay, these are all the words. Okay, now if you want to use the same thing and you want to add your own, obviously you know how to add. See this, ultimately you got all the values here and you can update this. This is set. You can update this set with your own list of words. Okay, so let it be here for this one, and I am going to create here. So for W in text, okay, W in, so this is NLTK stop words. So now I'm saying W in text, okay, And if W is in this NLTK stop words, then I'm removing W from text. So after NLTK stop words, after NLTK stop words, let's see. Okay, I'll comment this out. Okay. Okay, so this is NLTK list of, okay, so this is not what we want. So see here. So product, great, but is also removed. But is also in the stop words list. Okay. Now let's say you want but. Just for example, okay, we see the word but in the stop words, but we want to include it. Then we need to remove the word from the set. So we have already done set theory, right? Removing but from the NLTK stop words. Right? So how do we do NLTK stop words is? This is the set type. So how do you remove from set? Dot remove. And then you say but. So I've removed but. Okay, this is for example. Okay, so I don't think but is important, but just to show you how you can remove an existing word from your stop word. So when you run it, hopefully but will be removed, and you see but we got even in this case. Okay, so once you have this, right, you don't have to import it again and again. That's why it says, the what you have on local drive here is already up to date. Okay. Yeah. So this is what you should do. Okay. So this was our step number 3, right? Stop words, removal of stop words. Okay. Next thing is called stemming. What is stemming? So stemming, okay, stem. So when you look at a tree, this is how I remember. See, when you look at a tree, you have stem, right? What happens? You have a big trunk, and from there you get stem. You get stemming. Stemming means you are taking out from something. Okay. So if your word is like, say, help, so you can have words like helped, helping, helper. Okay. So stemming is taking the word and going down to the root word. Changing the word to its root. One of the method, and see again, you can create your own method. See, ultimately, all these are what? These are all advanced version of string utilization. It creates a lot of dictionary. So dictionary you can create, and dictionary you can say root word is help, and the values are helper, helping, helped, helpness, whatever, right? So whenever you have the value in the given value, you replace the value of that index, right? So what I'm trying to say is you create this as dictionary, okay, and you have the root node, okay, and this is your list. So you check for the words in the list, and here also you can have help, okay. Help will also be here. So you keep on building multiple dictionaries, right? You can also do it, you can, avoid using NLTK. You can create your own stuff. Only thing is, if you create your own stuff, it will take a lot of time for you to do that. But in the advanced version of NLTK, right, we create, like, for example, the work that we do, our words may not be like simple grammar, right? The NLTK is based on the grammar. So people who understands grammar can build it, but our work is little different, right? It's more technical. So we have to build our own stemming. We have to build our own stop words and things like that. Okay. So this is actually in library just a dictionary. Okay. With multiple indexes. So if you find a word in these values, this should be replaced with its index. That's it. Called Porter stemmer. Okay, so we'll use that. So you have from NLTK dot stem import Porter stemmer. Okay, so we'll create an object called stemmer equal to Porter stemmer text equal to, okay, and we need to take each word from text and put it in stemmer. Okay, so we have stemmer.stem, where we have to put each word. So we'll take that word and we convert into a list. So how to get each word from the text? So we'll say for W in text. Okay, so for W in text, and then the output that we get, the output W that we get, we put it in stemmer. So stemmer dot stem. Okay, and you put W here. Why stemmer is giving red here? Spelling is wrong. Okay, it's probably because of we have not had. Yeah. So stemmer dot stem, okay, word. So this word will come out from the text, and then output we will put it as a list. Now the error will go. Okay. So now you see, I'm going to move. Okay, let me comment this. Now let me move this here. Okay, text after stemming. In fact, let me not comment it. We can see if any words have changed or not. So see, product remains product, great, great, but, not, like, color. So we have not, okay, so stemming has really not worked because all of these words are your root word. Okay, so let me add some text here just to make it more interesting. Product is great, but I am not liking the color. Liking the color. Okay. So enter output becomes your list. That's it. This is like that. So you're saying for, see, one line for loop. Okay. So if your logic here, see, when you have logic for one line, whether it is for loop or condition, you can do something like this. Here, my logic is only one line. But if I had multiple lines of logic, then this would have failed. Here I have only one line of logic. So I can write one line of logic and entire output will become part of speech tagging or pause tagging. You want to understand, okay, whether it is a noun or pronoun, right? That's what we say. So there are 8 parts of speech, correct? So noun is generally for person, place, or thing, correct? Like Saurabh is a name, person, right? It become a noun. It's a I would say grammatical word which deals with the roles, okay, they play, like your 8 parts of speeches. Noun, verb, etc. Right? POS text, something like this, equal to your NLTK dot pause tag, and then you pass the text here. Okay, now you print so what happens here. Okay, pause tagging will give um, what we call tags, like you have NN for noun, something like that. Okay, pause tagging in NLP. Okay. Okay, so this is what you get. Okay, see this. CC is conjunction of coordinating. CD is digital cardinal. Okay, JJ is adjective. Okay, NN is singular noun. NNS is proper and plural noun. Okay, so these are different. Okay, I'll put this link also in our notes. See, the tokenizer is not installed. You have to install the tokenizer. Let me say here. But to perform this, we need to download any one tagger. Example we have is averaged perceptron tagger. Okay, need to download this. Okay, so this is the command to download it, NLTK, and now everything will work. I somehow missed that. I was focusing on the line which is giving error. Okay, now you see, this is the pause tagging of example. So example is noun, of is IN is what? IN is preposition and conjunction. NLTK is JJ, JJ is adjective, pause is noun, tag is noun, list is noun. Okay, so you can do that. Here now what I'll do, so we already have text. So I will say here, pause tagging of text. Okay, so we can, okay, I'll delete all of these, not required. So see, product is noun, great is JJ, JJ is your adjective, but is CC, conjunction of coordinating, int RB, RB will be PQR, RB, adverb, not is adverb. Okay, and we'll talk about lemmatizing. So lemmatizing is also like your stemming, reduces or takes a word, okay, to its core meaning. Okay, so we have something called as word lematizer. Okay, and let's try to use and see what we are trying to do here. So you are here, let's say, okay, so first I have to import, obviously, right? So NLTK dot stem. Okay, this is also in stem, and you are saying import word lematizer. Okay, now we say lematizer equal to word net lematizer, and then we will say here let's say, okay, very good will be very good. Okay, that's the basic form of the word. But your halves will bring it to half. Yes, this is okay. That's a small letter. Okay, half. Okay, this is what we are doing, right? So you come here and instead of stemmer, we'll use limitizer.limitize. Okay, print text after lematizer is your text. Okay, so these are the basic pre-processing steps that you need to perform on any NLP work that you do. You do any NLP work, these are the minimum, okay, work that you will have to do. The last one I'll do, okay, guys, very small, 10 minutes, and we'll wrap it up. Now, what is called sentiment analysis? Sentiment analysis. We need to read the sentiment, right? I told you in the beginning, sentiments, positive, negative. Read the sentiments of each sentence. Okay, so for this, we will use a data set, which is again on internet, okay, GitHub. Okay, so this is the data that we are going to use. It has amazon.csv somewhere. Okay, so it has a lot of data sets. Okay, this also you can use for your analysis. Okay, so I'm going to give it here. So amazon.csv. Okay, so we'll click on view raw. Okay, yeah, so this is the text. Okay, now you see, this is the text and this is the rating. So it says this is the text and the training data says this is 1. 1 is for positive rating. Okay, so we will take this and we will see why this data is positive rating. Okay, so let's take this and we will analyze our data set. Okay, so let's take this link, and so this is your text data and this is the rating. That means this is a positive text. 1 means positive, 0 means negative. Okay, so I'm going to read this and let's go back to our program or PyCharm, and this is where I'm going to use this. Okay, so I'm going to say link equal to this, right? Okay, now let's read the data. So I'm going to say data frame equal to PD. Okay, what is PD? PD is import pandas. So I need to say import pandas as PD, PD dot read CSV, and you pass the link here. Done? Okay, so data is read. If you want to see the data, you can say print df, and let's run this P2 here. Okay, now we will create a function where we'll perform all the pre-processing that we have done. Okay, so this app is freaking stupid. Freaking stupid means it's a negative sentence, isn't it? Okay, I love this app. Positive. Okay, so that's the data that we have. We need to understand. So now we'll do pre-processing. So let's create a function to perform all the pre-processing pre-processing steps of NLP analysis. Okay, so I'm going to say def pre-process NLP. This is what I'm going to call it. And I'm going to pass text here. And this should return a text which is pre-processed, right? So we need few libraries. So we need to import all the libraries here. So we need pandas, of course. Then you need stop words. Okay, so I can say from NLTK dot corpus. Okay, import stop words, right? We need sentiment analysis. We need word tokenize. So I'm going to say from NLTK dot tokenize. Okay, from tokenize import word tokenize. Okay, then lematizer. Okay, we will use lematizer. Okay, so from NLTK, I'm going to do few stuff. Okay, but as I said, you can decide with what all things you want to do, right? For example, Portuguese, you have to do normalize as well. Okay, so just to show that we are doing this, and finally, the purpose why I'm doing this is to use water function, which is a water library which has a sentiment intensity analyzer. It analyzes the intensity of a given text. Okay, so from NLTK dot sentiment dot, okay, water import sentiment intensity, how good or bad it is. Okay, so these are the libraries we are going to use, and we are going to use all of pre-processing, at least in the pre-processing part. So tokenize, right? First tokenize. Okay, we are assuming that text is all lowercase, so text equal to text dot lower, right? Then we say tokens equal to word tokenize text. Okay, so tokenize done. Then stop words. So text. Okay, I will use text itself. Okay, no worries. Everywhere we will use text. So what? Why to use different? Okay, so it is lowercase. This is tokenize. Okay, now text equal to your filter, right? So first we will create the word from word. So I'm going to say word for word in text, for word in text, if word not in, right? Not in stop words dot words, and we'll put English here. Okay, now this is for word in word, and what you get is word, and this we will create a list. So now we have list of words. List of words which do not have stop words. Okay, so now lematize, right? Okay, so ties. Okay, so text equal to, okay, okay, so before that we have to do this lem term. So I'm going to say lem equal to word net lematizer, right? This is the object we are creating, and now we have to lematize, right? So again, we will go through each word in the text. So I'm going to say for W in text, okay, for W in text, for W in text, fine. So for W in text will be the W, but this W we will convert into lematizer. So we will say lem dot lematize. This is the function. We will apply W to this, and then we'll create a list here. Okay, so same stuff. Oops, it is inside this. So same stuff, right? Okay, so far nothing is new. Okay, we are doing again what we have done. Now you see, okay, now we have filtered and we have created words. Now we have to join them as string, because ultimately we are predicting on the string. Okay, now join all the words as a line. Okay, words as we are predicting on each line of text. Correct? So, so we will say text equal to, or text output, something like, okay, out equal to space dot join, right? And we pass list, right? So this text is anyway list. So, okay, and then finally you return this. So you pass any text to it, this text will perform. Okay, this function you can save it. Okay, you can use it in any of your NLP analysis. Okay, you can use this NLP in any of your NLP analysis, right? Because we are performing everything here. Now you see, okay, if you look at this, okay, so you have review text and you have positive. Now we need to pass this review, df review, to this function, pre-process NLP. Okay, so how do we pass? So we have df, that's the data frame, and this is the column we want to pass, right? So df review text. Now, if you want to save it like a third column, you can say, you can create a different name, but I want to rewrite this. So I want to say rewrite this as, rewrite this one dot apply. Dot apply, if you do, and you apply, if you write this function name, each of these rows will be passed through this and will be replaced. So this will be replaced. So I'm not going to comment this. Okay, I'll have it here so that you can see the difference between original text and what we get after processing. Okay, so see here. Okay, so this is one of the best apps according to me, right? Something it says, right? This is one of the best apps. Okay, it's still doing this. Okay, it takes time here. Okay, it takes time. It's a text analysis, it takes time. Okay, so while it is performing that, okay, see, it has 20,000 rows. So obviously it is going to take time. Now, okay, I'm going to continue writing it. We'll see the output. Now we need to do what is called as NLTK sentiment analyzer. Okay, so we'll define a function called get sentiment, which will take the input string and give us the sentiment. Okay, so we will have 0 and 1. 0 means no sentiment and positive means 1. Okay, so we will now define a function get sentiment, which will return 1 for positive and 0 for non-positive. So even sometimes you might have neutral thing. Neutral thing also will be written as 0. Okay. So how do you do that? So sentiment and intensity analyzer function is there. We need to create an object of this. So I'm going to say analyzer equal to sentiment intensity analyzer. Okay. So this object is created. Now we'll write our function. So def get sentiment is what we want, right? Sentiment. Okay. Get sentiment, and this will take a text. Okay. And it will calculate score. Okay. So score will be given to each of the sentences. So analyzer dot polarity scores of each of your text. Okay. And what we are saying is sentiment. Okay. So this is one line. If I'm going to write. So if, okay, score of, okay, if score of, okay, now we will pass some text. So if score of pause is greater than 0, then it is positive, right? Then it is positive. That is 1. Else make it 0. Okay. And this will be our sentiment. So it is calculating. Okay. So we are not using anything. Okay. We are using inbuilt intensity analyzer, which will give us value. If it is neutral or negative, it gives 0. Anything positive, it will give you more than 0. Okay. It gives you point something. That means it is positive. And then you will return the sentiment. Okay. And we will create df sentiment here. Okay, df sentiment here, which will uh, take this df review dot apply, and this time we are applying get sentiment function, right? Not pre-processing, get sentiment. That's it. So this will give us the sentiment, and what we'll do is we'll compare, okay, the value, okay, the original sentiment versus what we got, and we can create a okay confusion matrix. So I'm going to print, so I'm going to say data frame after analyzing the sentiments, okay, slash n comma df, okay. And now create confusion matrix. How many we got it right? Confusion matrix with original one. Original is positive, right? And one that we created is sentiment. So we'll compare confusion matrix with positive and sentiment. So I'm going to import from sklearn dot matrix, okay, import confusion matrix, and I'm going to print the confusion matrix now. Okay, confusion matrix, okay, and sorry, okay, here I'm going to say confusion matrix, and original is df positive, and then the predicted is df sentiment, right? So I'm going to copy this positive and put it here. I'm going to copy the sentiment here, put it here. That's it. Okay. Now you can calculate your classification report, accuracy and all those things. We are done. Okay. So what we have done, we have taken the text, we have performed all the pre-processing stuff. And after pre-processing stuff, we are passing it to the intensity, you have this sentiment intensity analyzer, okay, which will analyze the intensity of the text between 0 and 1. So we are saying that anything more than 0 is positive, okay. And see this function, this data also has a sentiment, right? Given sentiment. So we are going to compare the one that we calculated with the one which is already given, okay. And then we will create a confusion matrix. We'll see how accurate our sentiment intensity analyzer has predicted the data. Cool. So with that, we'll end it here for today. And you can log off. I'll anyway share this code with you. But if you want to stick to me, I'll wait for it to run and see the result. So yep, you can free to log off if you have some work, or if you think you can spend 5-10 minutes with me. Let's see the output of this. Okay. Okay, so here the problem is with Vade lexicon. Okay, so we will need to import this here. Okay, so we need to import. This is after pre-processing is done, before we do intensity. Okay. These are the ones that we predicted correctly.
Okay. So these are the ones that we got wrong. 3636 and 576. These are what we classified wrong. Correct. So I'll put this also here so that you can check. Okay. So accuracy will be, okay, 1131 plus 14657 divided by, obviously, this plus 576 plus 3636. Okay, which equates to, if I do the calculation, it is 1131 plus 14657, which is 15788. 15788 divided by, okay, so plus 576 plus 3636, 20,000, right? Which is 15788 divided by 20,000. 78.94%. Okay, this is the accuracy. Okay. Cool. Now I'm going to show you. Okay, now I'm going to show you this, the one that we did for project, that library project. Okay. So for library project, okay, we need to create databases first. We need to create database, right? And then we need to add the value.